adlaw. I'm back after 3 days of not having uploaded a video. Just got so busy with so many stuffs to do. But anyways, I hope you are doing fine. If you are new to this channel, please don't forget to click the subscribe button and that notification bell below. After watching, please share to your friends, especially those who are incoming grade 11 students. Okay? So for today's video, I will be presenting to you about finding the domain and range of an exponential function. Actually, this is the continuation of the topic in my previous video about plotting the graph of an exponential function. In that video, I presented to you the standard form for exponential function, which is f of x equals a raised to x. But you should not be confused about the standard form because I will be presenting another standard form for this video, but this time I am using another variable. Okay, but they are just the same. Okay, so finding the domain and range of an exponential function. But before I go to the definition and example, the objectives or the objective. We only have one objective for this video. So at the end of this video, you should be able to find the domain and range of an exponential function given a graph and given a function. Okay? This lesson requires us to have a prior knowledge in the following. You should be able to recall on plotting the graph of exponential function. I have a video about these lessons. You have to watch that video so that you can relate to this lesson. Another is your knowledge on representing exponential functions through a graph and a table of values. And lastly, the definition, of course, the definition of an exponential function. Okay, so this is our objective and the prerequisite skills in order for us to understand this lesson properly. So that you can relate to this lesson, you have to have the knowledge on these prerequisite skills that I have mentioned. Okay, exponential function. The standard form of an exponential function is defined by, this is what I have mentioned earlier in my previous video about plotting the graph of an exponential function. We use the function f of x equals a raised to x. But for this video, we will be using this standard form f of x equals b raised to x. So do not be confused about this form because they are just the same. The variable. In that previous video, we used the variable a. In this video, we use the variable b. But they are just the same. So do not be confused about this form. So you have f of x is equal to b raised to x, where the b here should be greater than 0, but should not be equal to 1. And take note, our x still are all real numbers. Okay, so the x is represented by all real numbers. Okay, for this specific function, for this specific standard form of exponential function, the domain is defined by negative infinity up to positive infinity. And the range is from 0 to positive infinity. We have to take note that the 0 here in the range is also our horizontal asymptote. This is the line in which the graph of this function will move closer and closer but will never cross. This is the domain and range of an exponential function defined by the standard form f of x equals b raised to x. Okay, but for now, I will be presenting to you another form of exponential function. In this case, this is called a translation or the translated form of exponential function. But you have to take note that this transformation of exponential function is just based on the standard form. Okay? This time, we have here f of x equals a times the b raised to x minus h plus k. So we will try to understand the components of this transformation of exponential function. In our standard form, we cannot see a variable a there. we cannot see a variable h and k, but this time we have this one. But even if we do not have these variables in the standard form, it doesn't mean that they do not exist in the standard form. Okay, such that if we have a here in the standard form, the a is 1 because it's multiplied to b. So any number multiplied to a is just the number. That's why you have there the b. Then we also have the h here. So in the standard form, the h there is 0, and also the k there is 0. But you have to take note also that the domain of this function is the same with the standard. That is from negative infinity up to positive infinity. In the transformation form of exponential function, we have here the h and the k. So what is h and what do we mean by h here and what do we mean by k here? The h here is the horizontal translation, meaning the translation of the graph to the left or to the right. Okay, so for example, if the k is positive, the graph is translated to the left, meaning from the starting point of the standard form, your graph will move to the left, so units to the left. While if the h is negative, the graph is translated to the right, meaning if the h is negative, your graph will move units to the right. Okay. Again, if you have watched my video about plotting the graph of exponential function, you will understand how the h and k works. Okay. So h is the horizontal translation, while the k is the vertical translation. Your graph moves up or down. So if the k is positive, the graph is translated units upward. If the k is negative, your graph is translated units downward. Again, our domain is from negative infinity to positive infinity. We've got to remember to any form of exponential function, the domain is always from negative infinity to positive infinity. Now, how do we find the range? If the function is being expressed to this form, is expressed in form or translated form, you have two conditions to follow for the range. Okay? If a is less than 0, based on this translated form of exponential function, if a is less than 0, range should be from negative infinity up to the value of k. So whatever the value of k here, that is our value here. So our domain is from negative infinity up to the value for k. That if our a is less than 0. How about if a is greater than 0? If a is greater than 0, our range should be from the value of k up to the positive infinity. So this is the value for k here up to positive infinity. Again, I want to emphasize on this one here, the conditions here. If a is less than 0 and if a is greater than 0. So you have to take note of these conditions. Again, for all forms of exponential function, the domain should always be defined by negative infinity to positive infinity. Let's proceed to the examples. How about you are given this graph? Example 1. You are to find the domain and range of the following graph. So we will take this first example. How about, so I have here the domain ready. Now, if we are given this graph, okay, this is our horizontal asymptote that is in the x-axis, meaning our y is equal to 0. Now, given this graph, you have to take note that the graph of exponential function extends infinitely. So we have here an arrow. This means the arrow indicates that the graph can still be extended infinitely to the right, and the graph also can still be extended infinitely to the left. That's why our domain is from negative infinity to positive infinity. Okay, we can observe that the graph, as the graph moves closer and closer to this line, again, this line is what we call the asymptote. It moves downwards but will never cross this line no matter how we extend the line. Okay, that's why this is our horizontal asymptote. And the horizontal asymptote for this specific graph is y equals 0. That means our range is from 0 to positive infinity. The range is from 0 to positive infinity. This graph is a graph of the function f of x is equal to b raised to x. This is the graph of the standard form of the exponential function f of x equals b raised to x. Okay, let's proceed to the second example. Still again, the domain is defined by negative infinity up to positive infinity. All we need to do is to find the range now. For example, we are given this horizontal asymptote. The horizontal asymptote is the line y equals negative 6. Okay, that means our graph will never cross this line. How about for given this graph? Again, the graph will move infinitely upward and will move infinitely to the left. Now, if we are going to analyze the graph, again, the graph will never cross the line y equals negative 6, and our graph moves infinitely upward. The graph is translated 6 units downward. Okay, so of course, this is the translated form of the exponential function. So the range should be from, of course, the horizontal asymptote, which is negative 6, up to upward, up to positive infinity. So the range is from negative 6, which is this line here, but of course excluding the value y equals negative 6 because it will never cross, the graph will never cross the line, then upward. Now still we have, again, the domain is negative infinity up to positive infinity because as I've said, in whatever kind of the graph of exponential function, the domain stays the same. So they will only differ from with the range. For example, we will have this graph. Of course, if we have to draw the horizontal asymptote, of course, we have this line, which is y equals positive 3. So as the line goes upward and goes closer, closer, closer to the line y equals 3, but it will never cross this line y equals 3. Again, this line can extend infinitely downward and infinitely to the left. If we are going to analyze the range of this graph, the range of this graph shall be from negative infinity because it will go downward to negative infinity towards this line which is positive 3 but will never cross positive 3. So all you need to remember is just to look at the asymptote because the asymptote has something to do with the range and of course the direction of your graph. Okay, let's proceed to the second graph here. We have this graph. For example, we have draw the horizontal line. So the horizontal asymptote. So we have here the horizontal asymptote. Now, our horizontal asymptote is y equals 2. Therefore, our range shall start from positive 2 up to positive infinity. The 2 here is our horizontal asymptote of the graph up to positive infinity because the graph will move close infinitely upward and infinitely closer to 2. So let's proceed to the next given the function and not a graph. Okay, still we have the domain is negative infinity to positive infinity. We are given a function instead of a graph. So the first example is you are given negative 2 times 3 raised to x minus 1 plus 5. So here comes now the condition for the range. As I have mentioned earlier, To find the range given a function, we need to remember about the two conditions. So let's identify. A is negative 2, B is 3, H is negative 1, and K is positive 5. Now, as I've said, if A is less than 0, in this case A is negative 2, our domain or our range will be, again, if A is less than 0, our range shall start from negative infinity up to the k. In this case, our k is positive 5. This is our k. Now, our range, meaning, is from negative infinity because our a is less than 0. So, from negative infinity up to the value of k, which is positive 5. So, negative infinity to positive 5. And take note also, our positive 5 here is our horizontal asymptote. Okay, let's proceed to the next example. This time, our A is positive 3. A is positive 3 times 0.5 raised to x plus 2 minus 1. So since A is greater than 0, if A is greater than 0, our range shall start from the value of k up to positive infinity. So in this case, our k is negative 1. So therefore, our range would be from negative 1 up to positive infinity. This value here, the k, has very important role in identifying our range, and of course the value for a. Okay, if the a is greater than 0 or if the a is less than 0. Okay, let's proceed to the next example. How about we are given this function f of x equals 2 raised to x plus 3 minus 2. Now, how do we identify our a here? Since the a is not being specified, we are only given the b. This case here, our b is 2. Walay a diha. Then we have, of course, our k, which is negative 2, and our h is positive 3. Now, function is given like this. We need to remember that if a is not being specified, it is assumed to have the a value here, which is 1. You have to take note 1 times, because a times b. That means 1 times 2. So any value multiplied to 1 is the same value. That means if the a is not being written in the function, it goes to follow that the value of a is 1. So if the value of a is 1, that means, of course, a is greater than 0. So if the value of a is 1, that means our a is greater than 0. So our domain, of course, is the same from negative infinity to positive infinity. And again, our a is greater than 0. So our range shall start from the k, which is negative 2 up to positive infinity. So negative 2 up to positive infinity. Okay, let's proceed to the next example. Okay, still the domain is just the same, negative infinity up to positive infinity. Now, how about the range? This time, our a is, of course, the 1/3. This is our a, 1/3. And 1/3 is, of course, greater than 0. Now, in this case, we have the h, which is 4. Now, what is the value of k? This time, since k is not being specified, that goes to follow that our k is 0. Since there is no k written in the function, that goes to follow that k is 0. Because any value added to 0 is the same value. We can add plus 0 or we can subtract 0. This 0 has nothing to do with the function. That means our k is 0. So if a is greater than 0, so we will have our domain, by the way, our range is from 0, which is the k here, is not being specified in the function, our range is from 0 to positive infinity. We follow the second rule. Let's proceed to another example. Find the domain again, find the domain and range of the exponential function. In this case, we are given f of x equals 5 raised to x plus 7. This time, again, our a is not specified. So again, if a is not specified, we can say that a is 1. 1 times any number is the same number. So f of x equals 5 raised to x plus 7. This time, our age is not specified. So meaning our age is 0. But there is no problem with the age because it has nothing to do with the range. Now let's have positive 7. In this case, positive 7 is of course our k. Our a is equal to 1. Our k is equal to 7. So for this example, our domain is the same, from negative infinity to positive infinity. Of course, the range shall start from the k, which is positive 7, up to positive infinity. That is, a is greater than 0 because our a here is 1. That is the second rule. Okay, next, let's proceed to the next example. How about if we are given f of x equals negative 3 raised to x minus 1 plus 2. Okay, now this is very important here. We've got to remember that the negative here has nothing to do or has no bearing with the exponent x minus 1. Meaning, negative sign here is not part of the exponent here. Unless if we have a parenthesis here. That means negative 3 is part of the exponent. Meaning, that means the negative here, the negative sign here can be negative 1 times 3. Okay? So the negative sign is not for 3 but for the a, which is negative 1. Again, I want to make this clear. The negative sign is not for 3 because we have no parentheses. Unless if we have expression like this, that means negative 3 quantity raised to x minus 1. That means the negative is part of the exponent. So let's say, for example, negative 2 squared. Negative 2 squared is negative 4 because the negative here is not part of the exponent. And this is different if we have negative 2 quantity raised to 2. That means this is positive 4. So if this is the case, this means that we have the negative 1 times 2 squared. Therefore, for this example, our a is negative 1. Okay, our a is negative 1. And of course, the k is positive 2. So since a is negative 1, which is less than 0, that goes to follow that we need to use the first rule, which is from negative infinity up to k. In this case, our k is positive 2. I hope you have learned something from this video. Your best quote that reflects your approach. It's one small step for man, one giant leap for mankind. Okay? So let's do it a small step at a time. A small step at a time because it will eventually lead us to a greater learning in the future. So again, do not forget to subscribe, click that bell button, and share to your friends, especially those who are incoming grade 11 students. Thank you and God bless.